Right triangles only. Right triangles have a 90-degree angle. That is what classifies them as a right triangle. Now, what does trig do? Trig compares sides of right triangles. There's only one side that has a specific name, and then the other ones are based on where you put your angle, your theta angle. Okay, so this is the one that is always the same. It's across from the right angle. What is that called? The hypotenuse. This is always across from the 90-degree angle. How do I know that it's 90 degrees? It's got a little square on it, okay? When you see that little square, you know 90 degrees. All right, hypotenuse is directly across. Lucy, you are absolutely correct. These are called legs. Both of them are legs. So you have a hypotenuse and two legs. Now, based on where you put theta, and remember, theta is just a way that I define an angle that I'm looking at. I hate y'all didn't have a good geometry experience because there's so much good stuff with. Y'all learn hinge theorem? Okay. All right. Depending on where I put theta, here's the hinge theorem in a nutshell. If you put your hands together and I let theta be the angle that's formed in between my hands, right? The bigger theta gets, the bigger the side across from it gets, right? Does that make sense to you? If I shrink that angle in, then if I tied a string to my two middle fingers here, that string would get shorter as that angle gets smaller and bigger. That's hinge theorem, okay? That'll help you as you start doing some things with triangles, particularly here and calculus as you start working. So that's always a theorem that I go back and reference. Okay. Okay, good. If my theta is at the bottom, then the leg that touches, and whenever I say leg, that means I'm not looking at hypotenuse. Hypotenuse is across from the right angle. The leg that touches theta is called the adjacent side. And then the leg that never, ever, ever touches theta is the opposite side. Yeah. Opposite over hypotenuse. Okay, so we're going to learn some new ones too. The three basic trig functions, which are ways that allow us, we can find some missing sides of triangles. We can find some missing angles if it's a right triangle. Remember, this only works with what kind of triangles? Right triangles. Only works with, if you just had a regular, trig only works with right triangles. Okay? All right, y'all ready, Freddies? We have this nice, neat, when DJ taught me Algebra 3. She said Algebra 3, or maybe it was Trig, called Trig. I can't remember. Anyway, she told a story about an Indian princess named Sokotoa, and that's how we remember that story. And I'm looking at you just because it's your DJ. But she told y'all the Sokotoa story? Well, so yeah, but it stuck with me. But anyway, I can't remember the story, but I remember her telling this. Anyway, there's all kinds of acronyms to help you remember Sokotoa. I just remember Sokotoa. You can remember. I don't know that that's appropriate. I'm not gonna. I used to do a little bonus activity where whoever could come up with the best, most appropriate acronym for Sokotoa. But there's so many. The one that always stuck for whatever reason was some old hippie called another hippie tripping on acid. Why that? I don't know. Then I had to go G-rated with them because that was a little. But however you need to remember them, this is very important. The way you spell it is what matters. Okay, so I'm fixing to show you how it ties in. I was just giving you the acronym. So there are three basic trig functions, and from them all our other trig functions derive. They are sine, cosine, and tangent. Okay. If you look on your sheet, sine actually has an E on the end, cosine, but this is the abbreviation that is commonly used. This is the one that's on your calculator. But the sine of theta, as we always take the trig function of an angle, this is why the spelling is important, it's the length of the opposite side, that's the O, divided by the length of the hypotenuse. Cosine theta, what do you think that one is? Adjacent over hypotenuse, that's exactly right. How about tangent? Over adjacent. Now, what happens if you have a right triangle and you have two sides and you're missing a third? Oh. You did. Let's say I have this little right triangle like this, and I know that this is 3 and this is 4. How can I find the hypotenuse? So it's just a little geometry. Nope, you don't know trig functions here. This is a little geometry review.
Oh, you add them together, then you divide by
Close.
You add them together, then times it by 100.
Oh, square plus b squared. Yes.
That is exactly right. Okay. You can always, when given two sides of a right triangle, you can always find the missing third by plugging in this formula. A and B are both legs. That means they are the two that come together to make the 90 degree. If I'm going too fast, tell me. This is recap from geometry. A lot of this is recap from geometry. The new stuff is probably the cofunctions here. Yes, no, maybe so. Everybody okay? All right. So what would that side be? What's the hypotenuse of that triangle, by the way? 5. That's a 3, 4, 5 triangle, but yes. 9 plus 16, which is 25, which means that hypotenuse is 5. Okay. All right. I'm going to throw 2 more. I'm going to throw 3 more in here. I'm going to throw some cofunctions. These are really reciprocals of the trig functions. So here's your, yeah, we are. There's your sine, cosine, and tangent, the very first column. That's what we're doing. That's the reciprocal ones, the cofunctions. All right. Is it what? So it's the flip of them, but you have to remember which one goes with which. Okay, so cosecant is the reciprocal of sine. Okay, so cosecant theta is 1 over sine theta. And if it's 1 over sine theta, think about what reciprocal means. Then that means cosecant is, so look at what sine is and flip it. Okay. Now, everybody always wants to put cosecant and cosine together, but they don't go together. Cosecant is the reciprocal of sine. Okay, this is the abbreviation CSC. That just means reciprocal. It depends on how you want you can, or you can put it wherever. I think the way they've got it set up is that you would put this in the first box, this in the second box. But these are your notes. I mean, however you want to do them. See, no, see below it where it says reciprocal functions. This is they're just wanting you to show the relation of the leg and the hypotenuse. On the right, I would put this. Or vice versa, it doesn't matter. Or this. Whichever. All right, and then secant is the reciprocal of which one? If cosecant is the reciprocal of sine, then secant is probably the reciprocal of cosine. That's exactly right. So secant theta is going to be 1 over cosine theta. That's exactly right. Notice if you didn't spell SOHCAHTOA right in the very beginning, every single ratio you have is messed up. Secant theta is hypotenuse. We're going to pull all this together in just a second, and I think it'll make a little more sense. Let's just finish filling it out, and then we'll put it together. All right, cotangent. Do you? You should have learned all this in geometry, but I'm assuming you didn't, and we're tiptoeing through it. All right, cotangent is the reciprocal of tangent, of course. So tangent, notice you don't have co-function buttons on your calculator. You have sine, cosine, and tangent, so you'd have to do 1 divided by those on your calculator, but we'll get to calculator ones later. 1 over tan, which is adjacent over opposite. Still okay? Let's put it all into play. Look at number 1. So nice because all sides are given to me. Look where theta is because that definitely matters. 12 at the bottom, 13. Hypotenuse is always the longest side. It has to be the longest side or it doesn't make the right triangle. All right, so my theta is at the top this time. It's moved around on me. And I have to find all 3 trig functions plus the 3 reciprocal functions. So let's go through. The sine of theta here is what? Opposite over hypotenuse. So what's the opposite of theta over? Easy? Nope, leave it just like that. Cosine. Adjacent over hypotenuse. That's exactly right. Tangent. If I have radicals or anything like that, I might have to work with those, some rationalizing denominators or simplifying and things like that. But for right now, I'm good to go. Now the reciprocal functions, and the way the sheet's laid out for you, it makes it a little easier than what it probably should be. You just flip each one. So cosecant is the reciprocal of sine, which means it's what? 13 over 12. Or hypotenuse over opposite. I told you I thought once you saw it in play, it would make a little more sense to you. Secant would be 13 over 5. And cotangent easy enough? Pythagorean theorem to find the missing side. So we'll do that one. We'll jump down to number 3 and look at it. Maybe we should do 4 because it's got a radical in it. What you think? Okay. Let's look at number 4 together. So here's my triangle. I've got 6 theta, and I'll tell you, like I used to say all the time whenever I taught geometry for years and years and years, I am not a good drawer. Okay, so none of my stuff is to scale, so You don't have to tell me every time I draw something because I already know. All right, so I'm missing a side, right? I'm missing, which side am I missing? The hypotenuse, right? Or the C. So I'm going to do Pythagorean theorem to find that missing side. That's going to be my very first step. So I do leg squared plus leg squared equals whatever that hypotenuse comes out to be squared. What is 6 root 3 squared? 36 times 3. Because I'm multiplying in here, right? What is it? 36 times 3? What's the what is 36 times 3? 108. 108 plus 36, 144. My hypotenuse is 12. Once I get that piece of information, the trig functions are a cinch, right? So the sine of theta would be,
Wait, no. It's 36 over 12. Wait, you don't put 36?
what's the opposite side and the hypotenuse? I can and I do need to simplify that a bit. Square root of 3 over 2. Because when we form our unit circle, you're going to have to be able to do that, so you have to see why. How about cosine theta? Which is? How about tangent? 6 root 3 over the square root of 3. How about cosecant? 2 over square root of 3, but I can't leave it like that. I take this one and flip it. Because 6 and 12.
So it'll be 6 over 3, so it'll be 2 and answer.
You want to simplify it.
The answer is 2.
Go back to algebra 2. I didn't, yeah. Can't have a radical in the bottom, so you multiply the top and the bottom by the root that's in the bottom. So because there was a square root of 3 here, I multiplied the top by square root of 3 and the bottom by square root of 3. Square root of 3 times square root of 3 is just 3. Your calculator won't rationalize for you. And we're going to have to get exact answers because that's how we're going to do unit circle. All right, try the next one. How about secant? Secant, oh, that was an easy one. The next one, so I got 1 over square root of 3, but I can't leave the square root of 3 in the bottom. So I do root 3, root 3. What do you mean memorize them? And it's only those 3. Everything else comes off of those 3. So just remember SOHCAHTOA. I bet you will. I bet you will. SOHCAHTOA. SOHCAHTOA. All right, let's make it a little bit harder. Flip it over. Oh, you have to make the triangle yourself. Look at number 5. Stop, Carter. What the heck? No. Tangent theta. 7 over 24. And it says, use the given trig function or trig value to find all the remaining function values. All right, so Carter says make a triangle. Okay. It's got to be a right triangle. Where should I put theta?
So 7 would go.
Somebody said on the bottom. Okay, I'll put it on the bottom.
So
Across
across from it would be 7.
from it would be 7.
And then on the thing where the theta is.
No. No, that's. Oh, wait, yeah.
Toa.
And then 24 squared is, I have no idea.
So now I got to use my calculator, right? 7 squared plus 24 squared equals whatever this is squared.
Oh,
What?
25.
25.
Plus 49.
25.
What's it come out to be on this side? C is 25 is what y'all are saying. It's 25.
No, what number is it?
25. 25.
576. 625 when you add them plus 49. 49.
Now I'm going to assume from here you can find the other trig functions, right? I want to skip down to the 30, 60, 90. I think for homework tonight, you're not going to do the homework page. You're just going to do the classwork page. And we'll hit the homework page tomorrow. This is the classwork. So just page 1 of the 2 pages. But don't lose page 2 because I can't run it for you again. That'll be tomorrow. Okay. Look at the special triangles down the bottom. Well, you can go back and figure out the rest of them now that I showed you how to. Right? Sine, cosine, tangent. Okay. You got 2 do y'all remember this from geometry? I do not remember Kinsey doing this either, and I fussed and fussed, and I sat down and made her do it. Oh, what? This is very important. I know. Okay. These are what we call special right triangles, and they're special because they come up all the time, and there's a pattern to the legs, okay? So with these special triangles, if you're only given one side, you can find all 3 sides, whereas Pythagorean theorem, you have to have 2 to find the third, right? Special rights, as long as you have one, you can find the other 2, okay? So 30, 60, 90. This would be my 60 degree up here. This would be my 30, and I just know that because I'm looking at which leg's shorter than the other, right? The bigger the angle, the longer the leg across from it. And then 45, 45, 90. If the angle's the same, what do you think about the legs? They have to be the same as well. That's an isosceles right triangle. Isosceles means 2 legs are the same. Okay. Here's what's special. We'll start with 45, 45, 90. It's the easiest. Whatever the length of this leg is, I know this leg has to be the same, right? If you take the side, that leg, and multiply it by the square root of 2, you'll get the hypotenuse every time. If I started with the hypotenuse and I needed to get the legs, right? So to go from leg to hypotenuse, I multiply by square root of 2. How would I go from hypotenuse to leg? Divide by the square root of 2. Okay? That's whenever we get to a little bit past just intro to geometry and we start working a little bit more. All right, 30, 60, 90. I always start from the short leg. Always start across from the 30 degree angle. If you're not there, make your way back there. The long leg is 2 times the short leg. No, that's the hypotenuse. The long leg is the square root of 3 times the short leg. Sorry. Y'all okay? So again, always make your way back to short leg. If I start with, let's say I had a 30, 60, 90. Yes. Let's say I started this triangle, let's say the end here was 18. What's the length of the short leg? 9. So I go to the short leg. How do I find the long leg? See how I had to make my way back to that short leg to use it? So this is short leg times square root of 3, 2 times the short leg. Okay, but you're always basing it off of the short leg length. That's the hardest part of third. Do y'all remember doing it now? Okay, so y'all did do it. Okay. You didn't do it? Okay. The hardest is whenever I start with the long leg. Like, for example, let's say this is, I don't know, 12. It won't be any other number than what? This is 60, this is 30. Where do I need to go? Short leg, always back to the short leg. How do I get to the short leg? Divide, you're exactly right, by square root of 3. To get from short leg to long leg, I multiply, so if I go backwards, I have to divide. I can't leave that radical in the bottom. Gross. So I end up with 12 root 3 over 3, which is 4 times the square root of 3. Now how do I get to the hypotenuse from there? Multiply it by 2. No, you can't leave that in the bottom. And there's a reason, and we'll get to it really soon. No, I kind of diverted. If you just took SAT or PSAT or whatever it was y'all just took, this comes up all the time. Okay, so now it asks you on the bottom. I don't know what it is. I don't know what exactly they're. I guess. Well, they're saying if theta is 30 degrees. Yeah, look. On the left, this is theta. So the sine of theta, that's still.
I don't get it. That's not giving.
I don't either. I'd rather you just write this and decide under special values of, yeah. So that you know. So that's it. So don't worry about the chart that's at the bottom, but I do want you to know all of this. So wherever you got to jot all this down over there, even if it's right here under the little heading there or something, somewhere on there so that you know. Okay? Or on the triangles themselves, you can put the X, the 2X, and all that. Just finish this one sheet front and back. Hold on to the second sheet. We'll pick up there tomorrow. That's my fault for running behind.